So good morning all, welcome to SAKALAVIDYA YouTube channel. Okay, still joining, right. Okay, very good morning all of you. Once again, I welcome you all. Okay. Vamshi Krishna Yadav, Lavanya, Swati, Avinash, Sai, Narendra, Sai, Vijhadari, Nani, Vaibhav, Prasad Chaudhary, Avinash, Shiv Prasad, Balu, Narla, Swati Singh, Pavan Kumar, Hemant, Hemasri, Kottapalli, Bunny. Who is Miss Bunny? Nagamalli, Sai Haran. Any new viewers are there? Subscribe and like and share. So now, okay. So now actually most of the topics have been completed. My suggestion is that even just you need to revise during these days. Even you watch once again. Okay, Hemasri, first you need to subscribe. Siva. Who is Siva? Right. Circles completed. Circles completed. Right. Today we are going to talk about combinations part 2. Combinations part 2. Sir, information कब तक notice? I have given through WhatsApp group. Okay, you might have not noticed that one. Yes, 12 videos. Yes, 12 videos are available. So my suggestion, all of you watch once again all the even previous videos also, starting from the videos. I started actually 27th March onwards. Our classes have been continuing, so that you can check each. Most of the models have been covered in each chapter. That's why better you go for the once again you repeat it, revise it. That will be useful. Even you can suggest to the juniors also, so that they may get a benefit from our classes. Thank you, Kausik. Prasad, yes. You are regular. Kalyani, Swati Singh, Avinash. Still joining? Govind, Avinash. Once again, all of you watch the first year syllabus as well as second year syllabus. Okay. I need to wait because scheduled time is 9:55. So now it is 9:51. Still 4 minutes is there. Let us wait. Siva Prasad. Not yet started classes. Yet to be started. Yesterday in part 1 actually I did conceptual mistake on second problem. So I will discuss second problem of yesterday's and then I will proceed for the other problems. Okay? Right, because the second problem is option is third one, r multiplied by NCR, that I have done r factorial into NCR. That is incorrect. So I need to rectify it. So sorry for the inconvenience. So now I will solve that problem and then I go for next today's problems. So first actually slowly first we discuss level 1 problems. Sometimes level 1 problems, one of the trigonometric ratios videos are not playing. Okay, Narendra, you mentioned that part so that we will check in our site. Okay. The AP Eamcet, not only Eamcet. Okay. One thing, Ishwar, actually you forward your syllabus first so that I will get to know. Okay. Even previous question papers also, if you have anything, you forward through the WhatsApp group. Govind, give my number to Ishwar so that I will receive the question papers of Eamcet, previous AP Eamcet question papers, so that in that level I will concentrate the classes. Okay, that's good. So these kind of suggestions need to be given instead of charting. Advise me, sir, today I am going to start my preparation. No problem, still you have a lot of time. You watch all my videos. Thank you. Definitely will get an idea. Thank you. Thank you, Madhu. Madhurima, how are you? Yes, 8639145403. 8639145403. Okay, Sumant. So first let me complete the second question of the part 1, so that after that we shall switch over to the today's problems. So Gundu Surya, have you subscribed? First of all, you need to subscribe. I am from Hyderabad, Madhu. Okay, I will start going. Wait. Still our regular viewers need to join. Sir, can I also join these classes? Why not? Everybody will join. But you need to be careful. You need to chart regarding to the only subject only. Other than subject, you need not chart, because we may be distracted and you may be distracted. So in order to not to distract from our classes, so we should confine to our discussion up to only subject related to the academic matters. Okay, Gundu Surya. Prasad, I know. Mannam Divya. But after completion of the each session, actually you need to give the suggestions and feedback. After completion of the session, nobody is actually following, only few, at least 4 or 5 members. But what about others? You need to give it. Okay, let us start now the second question. I will discuss the second question once again. Second question. N and R integers such that 1 less than or equal to or r less than or equal to n, then yes, okay, then n times n minus 1 c r minus 1 equals to first option ncr, second option n times ncr, third option r times ncr, fourth option is n minus 1 times ncr. Yes. So this is the question. See, first we have this formula. ncr is given by n factorial upon n minus r factorial and r factorial. Okay. Let us come to this one now. Here solution, this n times n minus 1 c r minus 1. With the help of this formula, this can be written n times n minus 1 factorial upon n minus 1 minus r plus 1 factorial, because r minus 1 need to be subtracted from n minus 1, so that you get n minus 1 minus r plus 1 factorial times r minus 1 factorial. So n into n minus factorial can be written n factorial. This will be 1 gets cancelled, n minus r factorial. But we have r minus 1 factorial. So let us do one thing. No problem. So multiply both numerator and denominator with r. So we get like this now. So this can be written r times n factorial upon this r into r minus 1 factorial is r factorial, n minus r factorial into r factorial. N factorial by n minus r factorial into r factorial is nothing but ncr. So that means we get r times ncr. That means third option is the right option. So yesterday actually, few of our viewers expressed that the problem was incorrect. Absolutely correct. The problem is incorrect. I have given incorrect solution. I solved incorrectly. So once again, sorry for the inconvenience. So now you correct this question, all of you. Second question. Am I visible to you, all of you? Am I visible to you, all of you? Am I audible? Are you able to hear my voice or not? Say yes or no. Yes. Yes, Kalyani. No. It's okay. Right. Okay. Clear now. Right. Thank you. Thank you, one and all. Thank you. Okay. Let us move to the okay. Wait now. I will check here itself only. I will correct it. Don't worry. Once again. It's perfect. Okay. Okay, now let us move to the 18th question. Yes, today's 18th question. 18th. 18th question. The value of 2 to the power of n times n factorial times 1 into 3 into 5 into so on to n minus 1 is, okay, first option 2n factorial, second is 4n factorial, third 2n factorial upon n, fourth one is n factorial, Okay, the value of 2 to the power of n times n factorial times 1 into 3 into 5 into dash dash 2n minus 1 is either 2n factorial or 4n factorial, 2n factorial by n, n factorial. N factorial cannot be equal to this one because n factorial equals to n times n minus 1, n minus 2 and so on, 3 into 2, 1. Fourth option and will be eliminated, either first or third or fourth. So let us first 2n factorial, let us simplify now. Solution. Consider 2n factorial. As for the definition of the factorial, 2n can be written 2n factorial 2n times 2n minus 1, 2n minus 2, 2n minus 3, 2n minus 4 and so on. It will be continued dash dash 4 into 3 into 2 into 1. So in these actually product we have even terms and also we have odd terms. So first let us do one thing now. This 2n is even number, 2n minus 2 even number, 2n minus 4 even number, 4 even number, 2 even number. Let us separate them. 2n multiplied by 2n minus 2, 2n minus 4 and dash dash 4 into 2. You put the bracket and multiplied by, here you can reverse order write down 1 into 3 into 5 into and so on to n minus 1 as the product of the odd factors. Now this 2n is divisible by 2, 2n minus 2 is divisible by 2, 2n minus 4 divisible by 2, 4 and 2 also. We can take 2 common, here 2 common, here 2 common, here 2 common and so on, 2 common and 2 common. That means if you take 2 commons from the each of the factors, the 2 get how many times actually? N times we will get it. So that means, so this can be written like this. If you take 2 common from each of the factors, we get 2 raised to n and we get n times n minus 1 and n minus 2 and so on dash dash 2 into this will be 1 into 1 into 3 into 5 into dash dash 2n minus 1. So just if you observe n into n minus 1, n minus 2 so on, this 3 into 2 into 1 is nothing but n factorial, n factorial. So now this can be written 2 to the power of n times n factorial and multiplied by 1 into 3 into 5 into and so on to n minus 1. So this is very important, please do remember. 2n factorial can be written as 2 to the power of n into n factorial times 1 into 3 into 5 so on up to 2n minus 1. 2n minus 1 is the one of the general forms of the odd number. 2n plus 1 or 2n minus 1, both will be same. So that's why here first option is the right option. First option is the right option. Nineteenth. If an equals to sigma r is equal to 0 to n 1 upon NCR, then sigma r is equal to 0 to n r upon NCR equals to yes, first option n minus 1 times an, second option n times an, third option half times n times an, fourth option an plus 1. This is the question. Just think all of you about this question for a while. After that I will start the question. So what is the answer for this one? So generally I will discuss the problems from basic level to the even level 2 level 3 problems are like that I will discuss. So these problems are very important in the regarding to the JEE mains also. This problem is very important for JEE mains as well as our Eamcet examination also. Okay, option 3. Good. Okay, let us see the solution. Option 3. How did you get option 3? An equals to sigma r is equal to 0 to n 1 upon NCR. Then we need to find out sigma r is equal to 0 to n r upon NCR equals to. So now let us say S equals to sigma r is equal to 0 to n r upon NCR. Expand the sigma. First r value 0 upon NC0 plus 1 upon NC1 plus 2 upon NC2 plus so on. It will be continued. Last value is n upon NCN. Reverse order write-down. Writing in reverse order. Even though if you write reverse order, you get S value itself only. So that is equal to, you get S is equal to, we can write n Cn. Sorry, 1 minute. Okay. Let us write reverse order. This is n upon, upon n upon NCN plus, before that we have n minus 1 upon NC n minus 1 plus n minus 2 upon NC n minus 2 and dash dash plus this will be 0 upon NCN. Adding these two, adding S plus S is equal to S, we get it now. See, it's very clear. NC0 and NCN both are same. NC0, NCN equals to NC0. You can get N plus 0, N upon, you get NC0 plus N minus 1 plus 1, N upon NC N minus 1 is same as NC1 plus next N minus 2 plus 2 is N, N upon NC2 and so on dash dash. Adding these two, see N upon NCN. Now take N common. If you take N common, what do you get now? 1 upon NC0 plus 1 upon NC1 plus so on dash dash 1 upon NCR general term plus 1 upon NCN. This can be written as a summation form. So N times this can be written sigma R, take the values from 0 to N. We can write 1 upon NCR, the general term we can write. See, from the given condition, see here 1 upon NCR sigma R is equal to 0 to N is nothing but AN. So that means, so this can be replaced AN, N times AN, but we need S value. Therefore, S is equal to N by 2 times AN or half times N times AN. This is the answer. Okay. Right. This is very important problem. Even it may be discussed in binomial theorem also. This problem is related to the binomial theorem as well as permutations and combination chapter. But actually, even though it may be given in the binomial theorem, it based on the concepts of combinations itself only. I hope you might have practiced this question. So now the question number 20. Question number 20. Okay. NCR plus 4 times NCR minus 1 plus 6 times NCR minus 2 plus 4 times NCR minus 3 plus NCR minus 4 equals to first one N plus 4 CR, second option N plus 4 CR minus 1, third 4 times NCR, fourth one is 11 times NCR. This is the question. Okay, all of you read the question carefully. Look at the screen, all of you. If any of our regular viewers are not there, please inform to them also, if you have an idea. Okay. NCR plus 4 times NCR minus 1, 6 times NCR minus 2, 4 times NCR minus 3. NCR minus 1 is equal to how much? Okay, so that means now the solution, this given expression, so this I will write like this: 4C0 NCR plus this 4 I will write 4C1 NCR minus 1. 6 I will write 4C2 NCR minus 2. 4 can be written 4C3. 4C3 means 4C1 only times NCR minus 3. This we can write 4C4. 4C4 is 1. N times CR minus 1. Very interesting factor, we shall get it. So what is the interesting factor means? Actually see, 0 plus R, n plus 4. Here n plus 4. R minus 1 plus 1 R minus 2 plus 2 R minus 3 plus 3 R minus plus 4 R. Here one wonderful identity we have, that is called identity. What is the identity means? I will write, that is Vandermon's identity. Vandermon's identity. What does Vandermon's identity state? So it is stated that Vandermon's identity, see, it is stated that MCR NCP plus MCR plus 1 NCP minus 1 plus MCR plus 2 NCP minus 2 and so on dash dash equals to, we can write like this: M plus N, and this P we need to take, that means this can be stated M plus N CP. Using this Vandermon's identity, here we can write N is added to 4 and we need to take R. So now the given expression becomes, using Vandermon's identity, the given expression becomes like this: N plus 4 C R. That's all. N plus 4 C R. That's why first option is the right option. Twenty-one. Okay, 21. The sum sigma I is equal to 0 to M 10 I. This is also 10 Ci notation. This is a different notation. 20 M minus I is maximum when M is first option 5, second option 10, third option is 15, fourth option is 20. So Mr. Miryala Kondareddy garu, please tell your son's ID, so that after completion of this session it will be checked by our technicians. Okay, no, not that, ID number. You give the ID number, Kondareddy garu. You need to give the ID number so that our technical team will go through it. I will inform them. It's not possible now. It will be after completion of the session. Where are you from, Mr. Kondareddy garu? So thank you for your concern. Really, I appreciate you. The parents need to take this kind of responsibility. Mr. Duke Addictor 125. Its name, it's not there. It's not there. No, I could remember. It's a different. The sum sigma I is equal to 0 to m 10 Ci multiplied by 20 Cmi is maximum when m is. If it is maximum, then we need to find out m value. Okay. So now the solution. The given expression first let us find out. Let us simplify. Sigma I is equal to 0. Mr. Kondaleddy Garu, please suggest direct your son to chat with this ID itself only, Miryala Kondaleddy, because that ID is not good. Even I don't suggest also. Okay. 10 Ci 20 Cm minus I. So this can be written expanded like this: 10 C0 20 Cm plus 10 C1 20 Cm minus 1 plus 10 C2 20 Cm minus 2 and dash dash. This will be written 10 Cm 20 C0. It's nothing but seems to be rather Vandermon's identity. With the help of Vandermon's identity, what shall we do? Add this one 10 plus 20 and m. So that means this can be written as a single term 30 Cm. Now, so when for which value of m the 30 Cm is maximum. So maximum means actually you take n is equal to 30. This is an even number. It attains maximum when m is equal to n by 2. That means 15. So therefore required answer m is equal to 15. When m is equal to 15, the 30 Cm, this coefficient becomes maximum. So third option is the right option. Third option is the right option. Right. Third option is the right option. Now 22nd question. 22nd. 22nd. If P and Q are the greatest values of greatest values of 2n CR and 2n minus 1 CR respectively, then the relationship between P and Q need to be established in this problem now. First one, P equals to 2Q. Second option, 2P is equal to Q. Third option, P equals to Q. Fourth option, P is equal to n times Q. So no problem, you can watch the, just I have completed only 2 or 3 problems that can be watched after completion of this session. You need not worry. So Kondal Reddy garu, please don't suggest such names, because such names actually doesn't actually look like good, my opinion. So being a parent, actually I don't suggest such type of words. Let him be kept his name itself only. Yeah, yours Mirial Kondal Reddy is nice. Let him be continued there. So I follow different books. Right. If P is the greatest value of 2n CR, Q is the greatest value of 2n minus 1 CR, then we need to establish relation between these two. Right. So first, so as to make relationship between these two, consider first P value. P is 2n CR. See, 2n is an even number. It is maximum at R is equal to 2n, even number, 2n by 2, n. Therefore, P max, not, sorry. Now P becomes, let us say this is something P1 you say. This is PB becomes P1 maximum. P1 maximum. P1 maximum is equal to 2n Cn. Say equation 1. Consider Q equals to 2n minus 1 CR. So 2n minus 1 is odd. It is maximum at R is equal to 2n minus 1 upon 2. So 2n minus 1, 2n minus 1, 2n minus 2, that will be n minus 1. So that's equal to, okay. Otherwise even n plus 1 also, plus 1 you take it, this cancel, you get n. So that means you say this will be Q1. Q is equal to Q1 maximum. The Q1 maximum will be 2n minus 1 C n. Say this is 2. This is 2. Okay, let us find out now. P by Q. Consider P by Q. P is equal to 2n Cn upon 2n minus 1 Cn. This 2n Cn can be written 2n factorial upon 2n minus n is n factorial and n factorial. Upon this will be 2n minus 1 factorial, 2n minus 1 n, that will be n minus 1 factorial, and n factorial right down. This we need to simplify. 2n factorial upon n factorial times n factorial multiplied by n minus 1 factorial into n factorial upon 2n minus 1 factorial. First n factorial gets cancelled. 2n factorial can be written as 2n times 2n minus 1 factorial times n minus 1 factorial upon this n factorial can be written as n times n minus 1 factorial into 2n minus 1 factorial. So these cancel. We have 2. So now the cross multiplication P is equal to 2 times Q. This is the answer. Okay, next, yes, option 1. 23, 23, 23. If n plus 1 C3 equals to 4 times NC2, then n equals to first option 12, second option 10, third option 16, fourth option 11. Fourth option 11. Okay, those who have joined today, new subscribers, subscribe, like and share our channel. N plus 1 C3 is equal to 4 times NC2. Then the value of n we need to find out. Let us see the solution. This n plus 1 C3 means we can write n plus 1 times, just subtract 1, you get n, subtract 1, n minus 1, upon 3 factorial is 6. 4 times, this is n times n minus 1 times by upon 2. 2 1 ja, 2 2 ja. This n into n minus 1, n into n minus 1 cancel. We have n plus 1 equals to 12. N equals to 12 minus 1, which is equal to 11. So that means fourth option is the right option. Fourth option is the right option. Okay, are you following now? Right. Even I have discussed the last yesterday question, second question also. There is some conceptual error that has been clarified today itself only. And please go through that question also. Right, option 4. Option 4. 24th one. 24th question. The least positive integral value of x which satisfies the inequality 10c x minus 1 is greater than 2 times 10c x is first option 7, second option is 8, third option is 9, fourth option is 10. This is the question. Right. The least positive integral value of x which satisfies the inequality 10c x minus 1 greater than 2 times 10cx, then the least positive integral value of x we need to find out. That means actually, see, let us solve it now. Given 10c x minus 1 is greater than 2 times 10cx. So this we can write reverse order item 2 times 10cx less than 10cn minus 1. So if you reverse the order, then equality changes. This we can write 10cx upon 10cx minus 1 is less than 1 upon 2. So we have one important formula. NCR upon NCR minus 1 is n minus r plus 1 upon r. So using this condition, this minus this, 10 minus x plus 1, we can write 11 minus x upon this x equal to 1 upon 2. Sorry, less than, not equal. 22 minus 2x less than x. 22 less than 3x. So x will be greater than 22 by 3. 22 divided by 3. 3 7 ja 21 and 1 7.3. So x will be greater than 7.3. Here what we are asked here? We are asked to find out least positive integral values. That means now set of positive integral values which is greater than 7.3 we need to write it. So that means set of positive integral values, possible values 8, 9, 10, 11, 12 and so on dash dash. Of all these, which will be the least value? So which will be the least value means obviously 8 will be the least value. Therefore least positive integral, that means integer value for x equals to 8. That means second option is the right option, not option 1. 7.3 means it won't take 7. Greater than 7.3. That will be 8 itself only. Twenty-fifth. If NCR minus 1 equals to, sorry. If NCR minus 1 is to, NCR is to NCR plus 1 equals to 2 is to 4 is to 5. Then order pair n comma r equals to first option 10 comma 4, second option 9 comma 7, third option 8 comma 3, fourth option 7 comma 2. Okay. Twenty-fifth solution. Here given NCR minus 1 is to NCR is to NCR plus 1 equals to 2 is to 4 is to 5. Here first ratio between these two write down. That is NCR upon NCR minus 1 can be written as 4 upon 2. This we can write n minus r plus 1 by r equals to 2. cross multiplication takes place, n minus r plus 1 equals to 2r. Now n minus 3r equals to minus 1. Say equation 1. We get an equation in n and r. Now let us move to this divided by this write down. NCR plus 1 upon NCR. Using shortcut n minus r, this equal to 5 upon 4. N minus r upon r plus 1 equals to 5 upon 4. Now the cross multiplication here takes place. So having been cross multiplied, what do you get now here? 4n minus 4r equals to 5r plus 5. Bring or transpose 5r this side so that we get 4n minus 9r equals to 5. Say equation 2. So now we need to solve these two equations so that we get n and r values. Yes, by using NCR by NCR minus 1. Yes, sum of a binomial theorem itself only. Right? So now 4n minus 9r equals to 5. N minus 3r equal to 5. Multiply with 1, multiply with 3. 4n minus 9r equals to 5. This will be minus 1. 4n minus 9r 5 is equal to 3n minus 9r equal to minus 3. Now subtraction takes place. Minus, this becomes plus, this becomes plus. 9r, 9r cancel. N equals to 8. So now as we determine the value of n so that we can find out r value from any one of the equations. So from 1, having been substituted n is equal to 8 here, you get 8 minus 3r equal to minus 1. Obviously 3r equals to 9. R is 3. Now therefore we need order pair n comma r, that is 8 comma 3. Choose your right option. Choose your right option. Okay. Right. So now select the right option, that is 8 comma 3. This is the solution follows. Next, so we need to discuss some concepts. Combinations under restrictions. Under restrictions. Combinations under restrictions. First one, number of combinations of n different things n different things n different things taken or at a time taken or at a time. Without restriction means NCR, we know. But first point, what is the first point need to be discussed means when P particular things P particular things P particular things are always included is. This is the restriction here. What is the restriction? The particular thing need to be always included. We should not actually neglect it. The particular thing always included means already out of R things one object has been selected. Now remaining how many objects will be there here? Sorry, out of R P things will be already selected. R minus P need to be selected from remaining N minus P. That's why we get like this. Remaining things are N minus P because already selected P particular things. Now we need to take away remaining R minus P. N minus P, C R minus P. So always remember one thing. This the without any condition NCR. Whenever P particular things are included means subtract free from total, subtract free from the selection. You remember like this. N minus P, C R minus P. Right. Next second one. When P particular things are never included that means they should be excluded always. Never included is. So never included means we need to keep the P things kept aside. Out of N remaining are actually how many? N minus P, but we need to select R itself only. So that means we get that will be N minus P, but we need to select R. That means you remember NCR without condition. P things are never included means subtract from top N minus P R. Included means from top, from bottom we need to subtract P. Like this you need to remember. Okay. Right. Next third point. When P particular things are not together so in the selections they should not together means without restriction minus with restriction. P particular things are included. P particular things are included means N minus P, C R minus P. This you remember. Next, second important point. Total number of combinations of n different things taken any number, taken any number, that means 0 or more, 0 or more at a time is, at a time is. Okay, what is the answer? You will expect it now. So what will be this concept? Total number of combinations of n different things taken any number. Taken any number means 0 or more at a time. That means, for example, you can select 0, NC0 or NC1 or NC2, NC3, NC4, even NCN. So total combinations we need to find out. So that means actually here you remember that will be like this: NC0 plus NC1 plus NC2 plus NC3 so on dash dash NCN. From binomial theorem we know this is 2 power n. So is 2 power n itself only. This is the hint. This is the hint. Next, third one. The total number of combinations means selections of n different things taken one or more, not 0, from starting from 1 or more at a time is. That means here hint, 1 or more means 1, 2, 3, 4 up to n. That can be done NC1 plus NC2 and so on NCN. So that is equal to 2 raised to n minus NC0. This is 2 raised to n minus 1. That is 2 to the power of n minus 1. So generally you may get confusion when do we apply this kind of problems. So when do we apply means, for example, how many ways can you invite 5 friends to for the dinner? How many ways can you invite your 5 friends to the dinner? So that means, for example, 5 friends are there. 5 friends can be invited. 1 friend 5C1, 2 friends 5C2, 3 friends 5C3, 4 friends 5C4, 5C5 ways. This is 5, this is 10, this also 10, this also 5, this also 5C5 is only one way. Adding 6, 16, 26, 31. Instead of doing this, simply you can write 2 to the power of 5 minus 1. 32 minus 1 is 31 ways you can invite your 5 friends to the dinner. So now I will give some more for identical selections also, from selections from the identical objects, not different objects. That I will discuss later, don't worry. In the JEE main section I will discuss. Just note down the formula, that's all. Because generally if any problem comes on that one, just apply the formula, that's all. But more explanation we needed for that one, so that I explain later in JEE main section. Now fourth one. Number of selections of R things are things, that means are objects, are things out of n identical, not different, identical things, identical things is only one way, only one, right? So first let me complete combinations, then after that I will start probability. Okay, next fifth one. Sir, where it is useful combination restrictions for selection of the cricket team, selection of any sports team, selection of committees, these restrictions are very very useful. Number of selections, number of selections of 0 or more things, more things, more things out of n identical things, n identical things, identical things is n plus 1, n plus 1, this is 1. Next sixth one, these are very important, so I will discuss later about these, all the stars. Number of selections, number of selections, selections of one or more, of one or more things out of n identical things, n identical things is simply n, because 0 is excluded, only n ways. Okay, this I will discuss one for fourth point, one for fourth point, yes, one for fourth point, yes, one only, right? So far we have discussed actually uh, regarding to the combinations concepts. So today evening by 7:30 we shall have the class. In that 7:30 class we shall discuss the problems on combinations, problems on based on these 6 concepts we shall discuss. Thank you, bye bye, see you.